The sweep transformation is an advanced way of creating sweep surfaces. Generally, a 2D contour curve is defined first by a set of curve parameters, for example height, width, radius, area. These parameters are then controlled and changed by functions while sweeping the contour along the path. We will use the contour curve from a previous tutorial. It generates 2D shapes starting from a circle, and ending as rectangular shape. A prepared sample is available from accessing Help, Documentation. Then clicking Sample and scrolling down to 11 Parametric Contour, and opening the sample. In this step, the 3D path, also called trajectory, is created, along which the contour curve will be swept. Note that any curve type can be used for such a path curve. For simplicity, we will create a B-spline curve. Choose CAD, Curves, More of the B-spline curve menu and select Planar B-spline curve. Set Y, Z, X, for the plane attribute. Set number of control vertices to 5. Set end position to 10. Press Execute. Rename the new scope F1 to Path. In the Scope Path Auxiliary, set the y-coordinate of PO2 to 1.5. Select PO3 as well as PO4 and set the y-coordinates to 3. Let's create an image curve that utilizes the sweep transformation in order to sweep along the path. Select Total Contour. Go to CAD, Curves and select Image Curve and set the name of the new image to Sweep Contour. From pull-down menu of the attribute Image Transformation, choose Create, and create a sweep transformation. Set the name of the transformation to Sweep. For the path of sweep, choose our curve from step 2, that is Path Curve. Create a parameter TS from the context menu of the field Path Parameter. Try out different values for TS in the range, from 0 to 1. Remember, the parameters height, width and weight as well as TS, are variable values of our contour. In this step, we encapsulate the curve in a feature definition so that it can be used for meta surfaces. Select all objects in the CAD tree, apart from the parameters and the scope path. Choose Create Feature Definition from the context menu. Set the type name to Sweep Def in the Attributes tab, make only Sweep Contour accessible. We do not need the other geometries for surface creation. Press Apply and close the dialog. Create a feature of sweep. Set the path curve and test it by changing its input. In this step, the tree is slightly reorganized and a function for the path parameter ts is created. Within the surface creation process, this parameter runs from 0 to 1, that is along the path curve in a linear manner. Select all objects apart from the scope path and create a new scope via CAD, Scope. Set the name of the new scope to Construction. Make it invisible by clicking on its scope icon in the tree. Next we'll create the linear function. Create a line via CAD, Curves, Line and name it Linear. Set the start position to 0, 0, 0. Set the end position to 1, 1, 0. While linear is still selected, choose CAD, Scope again and rename the new scope to Functions. Curve Linear is now automatically in this scope. This is the final step before surface creation. We have to create a curve engine that connects the 2D sweeping curve definition with the directional information of how the surface is controlled along the path. Select the feature definition sweep def. Go to CAD, Curves and select Curve Engine and set its name to Engine. Set an initial value of 1 for weight, height and width. Set the function linear as input for the path parameter ts. Choose the path curve as final input for the curve engine. Since the path parameter needs to run from 0 to 1, which is done by the function linear, we can now create an initial surface. While engine is still selected, choose CAD, Surfaces and select Meta Surface. Set the name of the new surface to Duct. Set the U and V resolution in the display options of Duct to 100 and 50, respectively, in order to have a smoother visualization. So far, the parameters weight, height and width can be changed, but they are constant while sweeping along the path. Why not create functions for them? Again, remember that the curve engine is an attribute coordinate system for the functions, which is currently the XY system. This is the default. Therefore, the functions need to be given in this system. Our curve linear is also in the XY system. As an example for a weight function, choose CAD, Curves, and click F-spline curve and rename the new curve to weight. If you cannot see the curve due to the surface in front, use the surface curve filters of the 3D view. Set the start position to 0, 1 divided by square root of 2, and 0. In order to have a circle at the beginning. Set the start tangent to 0 degree. Set the end position to 1, 5, and 0. Set the end tangent to 0 degree. Drag and drop weight into the scope functions. Select Engine and choose from the pull-down menu, Functions Weight, into the corresponding weight attribute field. For the remaining variables height and width, we can also introduce functions. Choose CAD, Curves, More and click Planar B-spline curve from the B-spline menu. Set number of control vertices to 4. Set a constant value of 1. Press Execute. Rename the new scope F1 to Height. Drag and drop height into the scope functions. Select Engine and select Height into the Height attribute field. Now the final function. Copy and paste the scope height and rename the new scope to width. Select Engine and select the curve in width into the width attribute field. Select some points of the new functions, for example PO2 and PO3 of height, and drag them in the Y direction in order to increase or decrease the height at the end of the surface. Any kind of curve type can be used to design the path, the contour, or the function curves along with the individual parameters. In this example, the control vertices of the path curve and the vertices of the functions are natural design variables in design studies and optimizations. Typically, designers prefer to minimize the number of free variables, design variables, to those which are likely to have the biggest influence on performance, for example with regard to fluid dynamics, and thus reduce the computational time and resources required for optimization studies. Therefore, it is important to consider the modeling method and definition of functional parameters. Note that the generated surface is a single NURB surface for which the settings can be controlled in the meta surface duct.